Welcome to Signal Ahead. I'm Alfred. Today's briefing, Theory and Foundations, Physics plus Math. Tuesday, August 04. This is the synthesis above the noise. Not the headlines, but the deep currents beneath them. Let's get into it. There's a peculiar mood hanging over theoretical physics and mathematics right now, and I want to begin not with an equation, but with a departure. A young mathematician wins the Fields Medal, the discipline's highest honor, awarded to those under 40 for work of extraordinary depth. And on the very morning of that triumph, he announces he is leaving academic mathematics for an artificial intelligence laboratory. One journalist who had written a profile of him remarked that the piece now read less like a celebration and more like a requiem for a field. And that phrase has lodged itself in my mind, because I think it captures something that a casual reader of science headlines would entirely miss. Here is the non-obvious thing. We are accustomed to a story in which artificial intelligence threatens the humanities, the arts, the professions, the soft, human, interpretive work. But the frontier where machines are now pressing hardest is precisely the opposite end of the spectrum. It is the most rigorous, the most formal, the most seemingly inhuman corner of intellectual life, proving theorems, tracing symmetries, deciding whether two physical theories are secretly the same. The domains we thought were safest, because they were governed by exact rules rather than taste, turn out to be the most exposed. And the reason is exactly that they are rule-governed. Where the rules of the game are known, a machine can learn to play. Consider a problem drawn from the physics of supersymmetric gauge theories. Two systems are described in wholly different language, different fields, different couplings, and the question is whether they are, in fact, the same theory wearing different clothes. Physicists call this a duality. Establishing a duality by hand can be fiendish. It amounts to showing that one description can be mutated, step by step, into the other. And recently, people have begun handing this to machine learning, treating it as a variation on a much older puzzle. The problem of deciding whether a tangled loop of string is genuinely knotted or merely looks it. Learning to unknot, learning to trace dualities. The machine is not being asked to have taste. It is being asked to navigate an enormous space of formal moves and find the path. That is precisely the kind of labor that has, until now, defined the working life of the theorist. So one reading of the moment is bleak. The field is being hollowed out. Its most gifted practitioners are walking toward the laboratories that build the tools. But I want to resist the requiem, at least for now, because if you actually look at what human theorists have been producing this same month, you see something that does not look like a discipline in retreat. You see a discipline going deeper into questions no machine has been asked to pose. Someone takes the notorious Jacobian conjecture, the deceptively simple claim that a polynomial map whose derivative never vanishes must be reversible, and digests a counterexample to a related formulation, the kind of careful autopsy that reveals why our intuitions failed. Someone else revisits the standard model of particle physics, the theory of all known matter, and asks whether its strange bookkeeping of forces might be encoded in an exotic algebraic structure, Jordan triples, the mathematics of quantum observables, reaching, as others have long reached, toward the octonions, that eight-dimensional number system that keeps appearing at the edge of fundamental physics like a face in the wallpaper. And in the foundations of mathematics itself, people are building two-dimensional versions of set theory, and discovering that if you are not careful about size, the old paradoxes, the ones that nearly toppled the whole edifice a century ago, come roaring back in new dress. That is the tension I want to sit with across this conversation. On one side, an automation that thrives precisely because these fields are formal, and that is now good enough to make a Fields Medalist reconsider his vocation. On the other, a body of work on black hole entropy and its logarithmic corrections, on the symmetries that live at the boundaries of space-time, on whether the universe must have had a beginning. That is not really about following rules at all. It is about deciding which rules are worth following. about asking the question in the first place, because here is what a machine that learns to unknot cannot yet do. It cannot tell you that unknotting was the interesting problem. It cannot look at the standard model's ugly asymmetries and feel that something beautiful is hiding underneath. That act of judgment, the conviction that a particular tangle is worth spending a decade on, remains, for the moment, stubbornly ours. So the state of the field is not death, and it is not business as usual. It is a renegotiation of what the human theorist is actually for. And over the next 2 segments, I want to trace where the machines are genuinely winning and where the deep, unsolved questions suggest there's a certain mood that settles over discipline when one of its most decorated young practitioners collects the highest honor it can bestow, and then within hours announces he's leaving to work at an artificial intelligence company. A profile written to celebrate a triumph reads, in the light of that departure, like a requiem. And the temptation is to hear in it a lament. The field is dying, the machines have won, the best minds are being poached, the cathedral is emptying out. That is the noise. I want to spend our time here on the current running underneath it, because the current tells a rather different story, one not of surrender, but of a discipline quietly reorganizing itself around a new question. Consider what the machines are actually being asked to do. There is work now on teaching a learning system to recognize when 2 supersymmetric gauge theories are secretly the same theory, to trace what physicists call a duality, to establish that 2 descriptions, superficially unrelated, describe an identical world. Mathematically, this reduces to something almost tactile, mutating a quiver, rearranging a diagram of arrows and nodes, and it turns out to be a cousin of the problem of learning to unknot, deciding whether a tangled loop is genuinely knotted or merely disguised. Now notice what has happened. The interesting object is no longer the answer. The interesting object is the recognition of sameness. When are 2 things, dressed in different clothes, the same thing? That question is older than any computer, and it is the deep current I want to follow. Because you find it everywhere in this material, once you tune your ear to it. There is a proposal to describe the particles of the standard model, the whole zoo of matter and force, through the algebra of Jordan pairs, a piece of mathematics invented for reasons that had nothing to do with electrons. There is a long-running effort to build the same model out of octonions, the 8-dimensional numbers that refuse to multiply in the orderly way we are taught. What is going on in these programs is not a search for a new prediction. It is a search for the right disguise to be seen through, the suspicion that the messy list of particles is a shadow cast by a single clean structure we have not yet learned to name. That is duality again, wearing the clothes of unification. 2 languages, and the hunch that they speak of one world. And here is where the philosophical stakes sharpen, because sameness is not free. There is beautiful, austere work in category theory showing that if you build a universe of sets inside a sufficiently rich 2-dimensional topos, and you fail to impose the right restraints on size, a paradox of the Burali-40 kind comes crawling back out, the old contradiction of the set of all ordinals, the collection too large to be a member of itself. The lesson is not merely technical. It is that the very act of gathering things together, of saying all of these are the same kind of object, carries a hidden cost, and if you are careless about scale, the structure collapses. Sameness must be paid for in constraints. There is no free unification. You see the same discipline of constraint in the physics of boundaries. When a field theory meets a null surface, the edge of spacetime, or the horizon of a black hole, new conserved charges appear that were invisible in the bulk, soft charges living on the edge, a whole infinite algebra of symmetries that the interior alone would never reveal. And there is a subtle ambiguity there, a zero mode, that turns into a genuine new observable. The moral echoes the algebra. What is redundant from one vantage becomes essential from another. What looks like a mere labeling freedom becomes, at the boundary, a thing you can in principle measure. The redundancy and the reality are 2 faces of one structure. So return to the young mathematician walking out the door toward the machine. It is easy to read that as an ending. I read it as the current surfacing. For centuries, the labor of this field was to compute, to grind out the answer, to invert the map, to trace the tangle by hand. Even the notorious old conjecture about polynomial maps with constant Jacobian and its recently digested counterexample is at bottom a question about when local invertibility guarantees global invertibility, when a thing that looks reversible everywhere nearby is genuinely reversible everywhere at once. That, too, is a question about whether local sameness scales up to global sameness, and it fails, sometimes, in ways nobody expected. What the machines are inheriting is precisely the grinding, the tracing, the mutating, the checking of whether two tangles are one. What they are not inheriting, at least not yet, is the taste for which question is worth asking, and the courage to suspect that two utterly different worlds are one world in disguise. The requiem, if it is one, is for a certain kind of human labor. The field itself is doing what it has always done, only more nakedly now, hunting for the hidden identity beneath the surface difference, and paying, in constraints and paradoxes and boundary charges, the exact price that Hunt demands. There is a story making the rounds that I want to hold up to the light, because it captures something about the moment we are in. A mathematician wins the highest honor the field can bestow, the medal handed out once every 4 years, the closest thing pure mathematics has to a coronation, and on the very morning the profile of him is published, hours after the prize is announced, he lets it be known that he's leaving the university world for one of the large artificial intelligence laboratories. The journalist who'd written the piece remarked, a little ruefully, that his profile read like a requiem for a field. A requiem, that's a strong word, and I don't think we should swallow it whole. But it's worth asking what, exactly, is being buried, and whether the burial is real or merely dramatic. Here is the first thing to watch. When a discipline's most decorated practitioners begin to move toward the machines, not away from thinking, mind you, but toward institutions that build thinking machines, it signals that the machines have become interesting to the kind of person who could have their pick of problems. That is not the same as saying mathematics is finished. It's saying that the frontier has, for some people, relocated. And you can see why, if you look at the actual work being produced right now rather than the headlines about it. Consider the effort to teach a machine to recognize when two physical theories are secretly the same theory, to trace what are called dualities between gauge theories, to establish that two elaborate descriptions are, underneath, one description wearing different clothes. The people doing this frame it, rather beautifully, as a variation on learning to unknot. And that phrase should give us pause, because it tells us that a deep conceptual act recognizing sameness across apparent difference is being reformulated as a task a learning system can attempt. Now the second-order implication is subtle, and I want to be careful here. It is not that the machine replaces the mathematician. It is that the machine changes what counts as a tractable question. For a long time, a conjecture might sit unresolved not because it was philosophically deep, but because verifying a particular case required computation no human could stomach. Establishing whether two quiver theories are dual is exactly that kind of drudgery-laden, combinatorially explosive labor. When you can hand that to a system, the human is freed to ask a different order of question, and also, uncomfortably, to wonder which of their skills were ever really theirs to begin with. But I'd resist the requiem for a deeper reason, and here the recent theoretical work is instructive. Look at what is still stubbornly, gloriously human in the corpus of this very month. There is a fresh digestion of a counterexample to a notorious conjecture about polynomial maps, a conjecture that says, roughly, if the local behavior is invertible everywhere, the global map should be invertible too. Someone found that this fails, and the work of understanding why it fails, of digesting the counterexample, is an act of comprehension no verification engine performs for you. There is the discovery or rediscovery that a certain algebraic structure, Jordan triples, of all things, sits underneath the standard model of particle physics, hinting that the particular gauge group's nature chose might not be arbitrary, but forced by some exceptional algebraic fact. That is not computation. That is taste, analogy, the willingness to say this reminds me of that, and to be right. And here is the deepest cut of all, the thing I most want you to carry away. The foundations themselves are shifting under our feet, not because of machines, but because of ideas. There's work this month on set-theoretic universes inside higher categories, showing that if you aren't careful about size, an ancient paradox, the Burali-40 paradox, The paradox of the ordinal of all ordinals comes roaring back even in these sophisticated new settings. That is a reminder that the ground of mathematics is not settled bedrock. It is being actively rebuilt, and the rebuilders are running into the same abysses that terrified logicians a century ago, only in new dress. No requiem there. That is a discipline at its most alive, staring into its own foundations and finding them not quite closed. So what should you watch for? Watch whether the migration of talent is a drain or a graft. If the best minds move to the machines and take their questions with them, the machines learn to ask better questions, and the questions loop back. That would be a graft, a field extending itself into a new organ. If instead the questions get flattened into whatever the machines can currently do, that would be the drain, and the requiem would earn its name. Watch too whether the conceptual acts, the recognizing of sameness, the digesting of a counterexample, the sensing that an exceptional algebra is hiding in the laws of physics, remain the province of people, or whether they too become tasks. My wager, for what it's worth, is that the frontier moves but does not vanish. Fields do not die, they metabolize, and the sound you're hearing, I suspect, is not a requiem. It's the awkward, hopeful noise of a discipline learning to eat something new. That's the signal for today. The noise will keep coming, we'll keep finding what's underneath it. This has been Signal Ahead with Alfred. Until next time.